And with that, we'll start in and share my screen, and we can talk about the coast of Maine. Okay. This is, as Suzanne said, this was like the fifth in a series about the Gulf of Maine. And really what it does is I'm starting at the Maine coast from north and heading south. Okay. Starting up in Washington County, what you hear of when on the news when they speak about Down East Maine, this is it. It's called the coast in Down East Maine is referred to as the Bold Coast. And as I said earlier, it's in Washington County. And the coast basically consists of cliffs and cobble beaches. And to reiterate here, cobble is basically a stone that's larger than a pebble, smaller than a boulder, about 2.5 to 10 inches in diameter. One of the things that's noticeable about this coast here is the steep cliffs that tend to form on the coast. And the reason for that is because the rock that's that this area is made out of is called diabase. It's an intrusive igneous rock, which means that it's magma that came up underground and it hardened underground. It has the same mineral composition as basalt, which is pretty much black. But one of the reasons why you see the cliffs here is because this diabase has vertical fractures all through it. And when the wind and the waves go through and cause erosion, the erosion pattern leaves steep cliffs. This is another example of what the Bold Coast looks like, and this is in Cutler, Maine. And actually, it's got the Bold Coast Trail. There's a roadway and some hiking paths that you can use if you wanted to go and see that. But you can see the steep cliffs, and here you got a looks like an inviting little cobble beach. Coming down a little bit further on the coast, you come to Jasper Beach in Machiasport, Maine. And this large berm, I want to say it goes for about half a mile. It's probably less, but it really is quite impressive when you see it. And you might make note of this mound of dirt right here. So Jasper Beach is located right up here in the corner of Maine, not too far from the Canadian border. And you can see that it's in the inside of a cove right here. That pile of materials was a bluff that I mentioned earlier. It was a bluff that's about 30 feet high. It's glacial outwash of stratified sand and gravel. And stratified means that it's in layers. But what that bluff does is it provides the sand that is used to polish and smooth the rocks on the beach. And this is a beach where the rocks are just very, very smooth, and they're all fairly, relatively small size, just a few inches in diameter at most. So the Jasper Beach itself is a misnomer, and sometimes the rock does look like Jasper, but that's not what it is. So the rocks have been rounded and polished by the waves and the sand. And what gives it the purplish color is a mineral called rhyolite, a rock called rhyolite, which is a volcanic rock. And rhyolite, and this is a piece that's not from Jasper Beach, but it ranges in color from a gray to a light pink. If you look at the Jasper Beach itself, you can see that there's all these like little scallops in at the shoreline. As they make these hills for the stones to fall down, you'll notice that the like these disc-shaped stones are higher higher on the mound. And those basically are volcanic stones. Probably a lot of them look like they might be basalt. These the rollers are the roundest ones which tumble to the bottom, and those are made out of quartz and granite. So the types of stones have to do with has to do with the shape that they take and how they react to the waves of the beach. This is a picture from Roque Bluff State Park. And Roque Bluff State Park is just south of Machiasport. And this is kind of interesting because when you see the word bluffs in there, we start out with Maine with a lot of rocky coast, then it goes to a lot of what we call bluffs. We'll be talking about that further on. But basically, a bluff is a pile of glacial till that was left there from the last ice age. One thing notable about this Roque Bluff State Park is that there's a beach probably a mile plus or a mile or so long. But the road that goes by the state park, if you keep driving on it, it literally drives straight into the ocean. And it's just a ramp, goes into the sea. And about 10 years ago, two ladies were driving on that road. They got disoriented at night. They ended up driving into the ocean, and the vehicle was found about 175 feet away, and they had both drowned. And interestingly enough, this past summer or this past spring, when my wife and I went up there, the road wasn't blocked. You could just drive off the end. Coming down a little bit further, towards like Addison, and you see a lot of the land will look like this. The rivers and mud flats, tidal rivers that actually extend well into the mainland and away from the coast. Coming down even more, now we're coming down into the Scudic Peninsula. Again, it's starting to be very rocky and cliffy. This is another picture of the Scudic Peninsula, and the Scudic Peninsula is actually part of of Acadia National Park. And this is Mount Desert Island right here, with Acadia on it. And Bar Harbor is right about here. So Scudic Point is across from Frenchman's Bay, across from Bar Harbor. One of the things that I find really interesting about Scudic Point is that it's a really rocky promenade, pretty much solid looking granite, and there's a number of these dikes that are basalt dikes that are coming up through it. And they're very pronounced and very distinctive. And one of the things about this is that and how this dike formed is that this granite was in place with a crack underneath it. Magma came up and it filled up and it hardened into this basalt. But the thing about it that's interesting too is that obviously the granite is a harder stone than basalt. And you can see here at the edge how the basalt has worn away more so than the granite itself. This is actually Bass Harbor Headlight, and it's really at the very tip of Acadia National Park in Tremont, Maine. In Acadia, what you generally find is a lot of granite. And this is an example of the shore of what you'd expect to see in Acadia, pieces of granite. Other parts of the park have more dramatic cliffs, but again, they're all granite. And this is actually a view of Otter Cove that's taken from Otter Point, which is the high point. This is Sand Beach in Acadia, And Sand Beach is noteworthy for a couple of things, but one of them, if you've ever gone there, is that the water is very cold. The other is that once you get this sand on you, it is very much near impossible to rinse it off. The sand at this sand beach, and sand beach is maybe kind of a misnomer, because sand beach is actually what you refer to as a shell beach. The sand itself is made of 50% or greater is shell fragments. And one of the things about a shell beach is that you seldom see a shell beach in a temperate climate. They're generally in warmer, more tropical type of climates. In sand beach sand, you have fragments of urchin spines, shell fragments, barnacles, quartz, and feldspar. And if you look at this section of sand here, and mind you, this 3 millimeters is really about this big, so this is magnified quite a bit. If you look at the pinkish or the reddish here, that's the feldspar. I'd say the white is quartz, but I'm sure that a lot of the white would be quartz, but I'm sure a number of it would be seashells too. There's several reasons why there's such a high shelf content in Sand Beach. One of them is that the water up northern Maine and the coast here is very cold, and it traps the gases that dissolve seashells. Carbon dioxide and oxygen in the gas is trapped there. It can't get out and act with the shells. The other reason for it is this island here. It's referred to as Old Soka. And what this island does is it channels the currents here towards Sand Beach. So you have cold water that doesn't dissolve the shells, and the current is actually pushing the material into the beach. And this is an interesting example because here's the sand beach, and there's a rocky headland here and a rocky headland here. And this is a pattern that we're going to see, especially as you get into southern Maine beaches and coast. The next thing I'd like to mention, speak about are the Damariscotta shell middens. Okay, and what the Damariscotta shell middens are a pile of shells that were left there by Native Americans. They're the largest shell middens north of Georgia, and they were among the largest shell middens in the world. About 12,000 years ago, the first inhabitants, indigenous people, however you want to term it, came into the area after the glacial period ended. In other words, the glacier had melted and people could come on and be on the land. The shell middens were used by 3 different native groups over time, and scientists have dated shells from the middens at about 8,000 years ago, 8,000 years old. And interestingly enough, American oysters were very common up until about 2,400 years ago. At that time, rising sea levels put colder water into the bays, which impacted oyster reproduction. It got too cold for the oysters to reproduce. What they did is they went up the rivers and they continued to thrive, the oyster population. This is the whaleback shell midden, and this is the shell midden that was in Damariscotta. It was in 1839, it was identified in the first Maine State Geological Survey. And this individual, Samuel T. Jackson, was the first state geologist and actually did much of the work towards identifying what we have for geology here in Maine. Originally, the shell midden was 1,650 feet long, 1,300 1,320 feet wide, 1,320 to 1,650 feet wide. So it was long and in some places almost as wide as it was long. In 1886, it started to be mined, and it was mined for 3 years. And 200 tons of shells were removed for chicken feed. And if you've ever raised chickens, one of the things about it is you feed chickens oyster shells to make their shells that much stronger. What the shells did is that the calcium carbonate from the shells made the soil alkaline. And because the soil had a reduced acidity, it preserved a number of artifacts. And there were shells, bones, pottery, and also stone artifacts found there. Also, there were bones of the extinct sea mink and the great auk that were found there. And the sea mink and the auk went extinct with the coming of the European settlers. The auk itself is not related to penguins, but they're actually about two plus feet tall. They're not out here anymore. These are some pictures from when the mining operation was going on at the whaleback midden in Damariscotta. You can see how high, in terms of the individual standing over here, you can see how high the middens went. And over here on the right is actually more shells there. And it looks like the boss is over here taking a stroll because he looks too well dressed to be mining those shells. This is the Glidden shell midden, and it's a cross from the whaleback midden, excuse me, on the Damariscotta River. This midden was smaller. It was like 492 feet long, 230 feet wide, and 26 feet deep. Okay, and it was never mined. And this kind of shows how the shells are broken up by weather, wind and tides, etc. The shells are broken up and it formed like a little bit of a slope down here. And this next picture kind of really shows how they've really worked to, I'm going to say it, reinforce the shore. You know, it's a natural hardening of the shore itself. And you can see that there has been some erosion here, but it's been more or less gradual. The shells themselves, oyster shells themselves, some of them have been found that are up to 20 inches long. And in terms of oyster shells that we see today, I'm thinking 3 or 4 inches is a good size oyster shell. Back in the day, some of them reached 20 inches. Next, moving down to Merry Meeting Bay. Merry Meeting Bay, I find, is one of the more interesting bodies of water on the coast of Maine. It's not a bay, it's not the ocean, and it's not a true estuary. Here it is up in here. You can see it's a ways away from the ocean itself. Geologically, it is considered an inland delta. Biologically, it's classified as tidal riverine. So it depends on how you're looking at it, is how you describe it. But Merry Meeting Bay is a body of fresh water about 17 miles from the ocean, and it has 5-foot tides. How that happens is Merry Meeting Bay sits at the confluence of 6 rivers. You got the Kennebunk, the Androscoggin, the Cathants, the Easton, the Abadasset, and the Muddy. Those 6 rivers make up nearly 40% of the Maine water, excuse me, Nearly 40% of Maine serves as a watershed for Merrymeeting Bay, with the Kennebuck and Androscoggin being the biggest, largest rivers. And these are just two pictures of the watersheds, one of the Androscoggin and the other of the Kennebec. And this obviously doesn't include the other four rivers, though so there's some overlap with it. Okay, why does Merrymeeting Bay experience freshwater tides? Um, the reason that happens is that the entire bay discharges through an area called the Chops. It's 600, an area 600 yards wide. It was carved by the glaciers, as was most of the Maine coast. In what geologists would call it is a sunken waterfall. Back when sea level was lower, there was a waterfall in this area. As sea level rose, the waterfall got covered with water. The high rate of discharge, meaning like the 6 rivers that are coming down and are going into the ocean at this point, the high rate of discharge limits the upstream movement of seawater. And it pretty much stops it because the salinity in Merrymeeting Bay is less than 1 part per thousand, and it is considered fresh water. The bay itself, remember, it's 17 miles away from the coast, is linked to the Gulf of Maine by the lower Kennebec River. The Kennebec River estuary actually is pretty large because it equals about 20% of the Maine tidal marshes. And in Maine, we have about 19,500 acres of salt marsh. So there's quite a few thousand acres of salt marsh in that area. The estuary has freshwater marshes dominated by wild rice. And it's a major stopover, and has been historically anyway, for migrating waterfowl. So much so that the Abenaki, Native Americans, called Merrymeeting Bay Quabacook, which means duck meeting place. And it's a spawning ground and a nursery for anadromous fish. By the 17th and 18th century, Maine's rivers and Merrymeeting Bay were degraded. They've been overfished, they've been dammed. You had increased sediment from poor agricultural and forestry practices. By the mid-20th century, 1950 or so, commercial and industrial uses caused the collapse of several major rivers, like the Androscoggin. Depleted dissolved oxygen in the rivers caused fish kills. The dams themselves interfered with fish spawning. It's hard for a fish to swim upriver when it hits a major wall. And the Androscoggin River itself was considered to be one of the most polluted rivers in the United States. In 1972, 2 things took place that did Merrymeeting Bay, and I dare say the rest of the population in the country, a world of good. One of them was the Clean Water Act was put into place. And the other was that DDT, the use of DDT was banned within the United States. Since that time, there's been a substantial recovery of the Androscoggin River. And also, the area around Merrymeeting Bay has become one of the most, has one of the larger populations of eagles in the state that live in that area. And just to mention this a little bit, the problem with DDT was that it built up in the tissues of the birds, and when the female eagle laid the eggs, the eggshells were very weak and they would break, wouldn't hatch. So today, Merry Meeting Day, it's permanently shallower. And that's because there's a lot of sediment from the forestry and agricultural practices that accumulated down there. Also, in the sediment itself, there are a lot of toxic substances. Remember, Androscoggin River was among the most polluted. Toxins settle in the sediment. And fish runs today are a fraction of what they used to be. Though, if you see in the effort that the state's making with fish ladders and dam removal, hopefully that will improve. Move down a little bit to Popham Beach, which looks pretty nice in this picture, but in the last storm, Popham Beach lost, sections of Popham Beach lost about 10 feet of dunes. Reed State Park, which is a peninsula or two south of where Popham is, Phillipsburg, lost about 17 feet of dunes. So the last two storms really nailed not just the southern Maine, but like this mid-coast area. And interesting enough, this mid-coast area is where much of the shore is made out of embankment or glacial till stacked up. What are the sources of sand for the main beaches? Well, the first one that starts out is glacial till drop near the shoreline. It gets eroded and weathers and it breaks down and forms sand. The other source of sand is sediment flowing from rivers. Sand itself builds beaches. And, if you lived in Saco or if you're aware of what's going on at Camp Ellis in Saco, a lot of the beach is wearing away. And the reason for that is because of a jetty that was built by the Army Corps of Engineers, and it's starving the Camp Ellis of sand. And literally, big storms come up, houses get washed away. Another picture of Popham Beach, and I have to say it's one of my favorites, and it'll be interesting to see how it looks come spring. Chicks on the beach, always a good thing for summer. These are piping plover chicks, and you probably know that these are an endangered species. And I know that there are some that nest at the Wells Reserve. But here's what we got about the piping plovers. In 2023, Maine Audubon said there were 157 breeding pairs in the state. 201 chicks survived to fledge. Well, that's progress, okay? But consider this, that in order for the population to increase and thrive, you have to have a fledge rate of 1.5 chicks per mating pair. This past year, it was actually 1.28. So the number of birds that fledged isn't enough for a sustainable recovery of the population. And it has been a slow recovery. And in 1980, and I've gotten two different numbers on this. One of the items says there were 6 mating pairs, the other one says 10. Either way you describe it, you went from 10 mating pairs or 6 mating pairs in 1980 to 157 43 years later. It really isn't a huge increase in the population, especially when you consider the amount of effort that's been made with endangered species like this one. And again, they're little, the fledglings, they're referred to as cotton balls on toothpicks. And literally and I'll show you, I have a picture of where they would nest in wells, but literally, they have a long run to get to the shore. And one of the things is if you ever see birds, especially small birds like this on the beach, stay clear away from them because one, you're tall and you might scare them, but they're looking for food and they're not big, they don't have a lot of fat on them, so they need to eat. and not waste energy. I did add this and included it because I was intrigued with the color of the eggs. And if you look at the sand and you look at the eggs, they're very much camouflaged, which you might say they need to be, considering that these birds pretty much nest out in the open. Coming down to bluffs. Much of the Maine coast has bluffs, and a bluff is a steep shoreline slope made out of sediment that's 3 feet or more above the high tide mark. This is the bluff face right here, and down here is the bluff toe. Okay, the bluff toe is the material that's at the base of the bluff. And this is bluffs wear down. It's just a natural process. And if you're a property owner, you don't want it to happen to yours, I guess. So you start with your open, your straight face here. You can see that as the waves come in, it washes away and eats away at the base. That causes the slope to sag down, and eventually the cycle will start over again. So these are shoreline slopes, okay? This is a stable shoreline. You have a gentle slope of less than 10 degrees. This bluff face here would be covered with vegetation. You wouldn't expect to see any bare ground. Unstable slopes are 10 to 20 degrees steeper, sparse vegetation. You see bare ground on there too. And usually if you see a tree on an unstable slope, it'll grow bent. And then you got the highly unstable slopes down here at the bottom. Very steep, greater than 20 degrees. There's little, if any, vegetation on it. And if you look at the bottom of the slope, you're liable to see dead or dying trees that have slid off the slope. This is a good example of an unstable bluff. You've got curved tree trunks. You can see it like this here. The roots are exposed. You got bare ground right here, and it's a pretty steep slope. You know, a storm comes in and hits this. There's not a lot to protect it. This is an example of a bluff off the Damariscotta River in Brunswick, and you can see how the slope up here has slid down. You can see it down in this area, and if you look over in here, it looks like there's probably some trees or some roots down there too. This type of slope is it's a steep slope. And it, with rain or storms, it will erode. This is one of the biggest, I'm going to call it one of the biggest landslides that I know of that's happened on the coast. I'm sure there might have been bigger, but this is within memory. This happened in Rockland, Maine in April 16th of 1996. Seems like a lifetime ago. But anyway, what happens here, as you can see, that all around here, the bluff, the slope, has shifted into the ocean. A couple of things to notice here. If you look right here, you'll see that there's a sand and gravel type of mix. Glacial till. It was material that was dropped there by the glacier. Okay. This house here, pay attention to, please. And this home right here, and you can see, here's the first house. You're probably 15 to 20 feet. The garage is dropped below the house, and actually probably even more than that. This is the home on the other side. And again, this happened within a very short period of time. Nobody died in it, but if they were in the house, they wouldn't have come out very easily, that's for sure. And if you look up here, you can see too, that if you look at this soil, again, it looks like that, gravelly, sandy type of glacial glacial till. This is what it looks like by Google Earth. You can still see where it has gone out into the shoreline area, but it's pretty much grown up at this point. And I'm thinking they were very motivated to plant it because nobody wants to lose any more houses. And as a note, you might notice this is Samoset Road, the Samoset Resort that is kind of a famous resort, I guess, is up in that area. This last example is of a stable bluff. You have vegetation on the bluff face. Over here on the shoreline, there's a marsh. You know, this surface here has the protection of the marsh and the vegetation to hold it together. The other thing I'd make note of it is while it's somewhat steep, it's not really all that high. Moving down to Casco Bay. Casco Bay has so many islands in it, is that the islands in Casco Bay have been referred to as the Calendar Islands because it was originally said that there was one for every day of the year. But the main island institute has come up with the number as being 166. So no matter what, there were quite a few islands in Casco Bay. Okay, moving down to Saco Bay, getting closer to home here. And speaking of being close to home, here's Winslow Homer. He has done a lot of interesting artwork in this area. Okay, Saco Bay itself is the longest beach and salt marsh system in Maine, it being 10 miles long. This is East Point Sanctuary in Biddeford, and put it into context, right here, this is Biddeford Pool, and this is the Biddeford Pool Beach. Fortune's Rock would be over this way. Camp Ellis, Saco would be here, and Old Orchard Beach is right here. So it goes from the East Point Sanctuary to Prout's Neck in Scarborough. Prout's Neck is where Winslow Homer had his painting workshop. Here's a good pretty good picture of East Point Sanctuary. So it's right here. You can see the rocky shore. Biddeford Pool is back down here. The beach is over on this surface, and for reference, Hills Beach and University of New England is right over in this area right here. In regards to East Point Sanctuary, there's about 10 feet of glacial till on top of the sanctuary itself. The beach areas there have very little sand. They're mostly cobble. And that's because the sand erodes towards the Biddeford Pool beaches. Most of the rock and on the East Point Sanctuary, and I will say a lot of the coastal rock here in southern Maine is metamorphic. And this happens to be at East Point Sanctuary is metamorphic sandstone and limey shale. And if you look right here, this is a basalt dike, similar to the one at Schoodic Point, except not quite as impressive. But the dikes down at the East Point Sanctuary can be up to 4 feet wide. Another thing here is that this rock is mostly vertical at a steep angle. Sedimentary rock forms flat, and this is vertical. So there's been quite a bit of shifting in the earth for this stone to come like this. And leaving the Biddeford Pool area, this is the Wood Islands Lighthouse as seen from the East Point Sanctuary. It too, one of these buildings here was destroyed in the last storm. Moving down to the southern Maine coast, from Kittley to Portland, we have a scallop coastline. Basically, there are rocky outcrops and sandy beaches. Okay, your rocky outcrops would be Cape Nettic, and the sandy beach, the beach next to it that would be located in association with Cape Nettic would be Long Sands Beach in York. Cape Arundel would be in regards to the Ogunquit and Wells beaches. The East Point Sanctuary would be the rocky outcrop by the Goose Rocks and Biddeford Pool beaches. And Prout's Neck would be the outcrop for the Old Orchard Beach and Ferry Beach beaches. So basically a scallop coastline with rocky outcrops and beaches in between. The coast of Maine itself has 70 miles of sand and cobble beaches, and half of those beaches are within between Kittery and Portland. So in this 45 miles, we have the majority of the beaches in the state. Beach slope, and this is Pine Point Beach in Old Orchard. One of the things about Pine Point Beach is it's really quite flat, and beach slope itself is determined by the sand grain size. If you have fine sand, like at this Pine Point Beach, you have a gently sloping flat beach. If you have coarser sand, you have steeper slope beaches. And if you go down other parts of Old Orchard towards the other end of Old Orchard, the beaches, you will find that the beach is much steeper. Okay, and that has to do with the coarseness or fineness of the sand. Due to the sand's ability to absorb water, fine sand absorbs very little water. Most of the wave flows back into the ocean. Coarse sand absorbs more water, and the wave swash ends up leaving the material sand up on the shore. Moving down to Wells Reserve. Okay, so here we have the Little River, salt marsh, and the barrier beach system that allowed it to occur. And this right here is the whole thing is the estuary, but this here is where the river goes off into the ocean. Okay, the sand for the Wells Reserve and the barrier beach is glacial deposits, and most of it is likely from the Great Sanford submarine fan. And this is a glacial fan is a lot like if you ever look at a puddle or a stream where it enters into a lake, you'll notice that sand is dragged in, and you'll see a pattern of sand where the water flows in. Well, that's what basically that's what forms that's a fan. And when the glacier melted, huge glacial fans, submarine fans, were located in various areas. And there's one actually in Kennebunk and Sanford areas. And that material from that submarine fan is the source of the material for the barrier beach and the marsh. This is one of the last pictures of the estuary with the salt marsh here. And you might notice that the edge of the estuary itself, the sand is very steep. And I've noticed that with several other estuaries, is that there's the sand where closer you get to the ocean, the sand itself will be have quite a steep slope. In terms of the piping plovers, they would be nesting somewhere off into this area, a little bit further towards Wells itself. Okay, here's some of the problems that we're having with the Maine coast, and we've seen this in the last few storms. We have high tides and storm surge on top of it. High tides damage the salt marshes. One, it's putting a lot of salt in them. The storms come through and beat them up. Salt itself comes in and it will go through and it will flood the land adjacent to the marsh. It ends up killing the trees. And you'll see this, there are some at the Wells Reserve, that salt marsh, over in the distance, there are some trees that are dead. But in particular, I know in the southern coast, like Virginia and those areas, there are a number of ghost forests where saltwater intrusion has come in and killed all the trees off. Okay. The other problem with these storms is the erosions of the dunes, beaches, and bluffs. The dunes tend to protect the shore. You know, if you lose 10 feet, like is at Popham, or 17 feet at Reed State Park, you're losing a tremendous amount of protection. Okay. And we had two storms, actually two or three storms, very, very close in time. And there wasn't a chance. The first storm caused damage. The second storm caused that much more. The other problem with the higher tides is aquifer contamination with salt water. That has to do with like marshes and the shore itself. But in the last oh, the Portland Press Herald had this article back in January about sea level rise in Maine. And the state of Maine has a calculator that you can go to, and it will tell you what you can expect to see for sea level rise. But this is quite interesting. Starting out with Portland, got two examples. One's Portland, the other is Kennebunk. It projected a 1.6 sea level rise by 2050. This is something that is in a good case scenario, that would be a reasonable amount to expect in terms of sea level rise. Okay, with that sea level rise, look at what you lose of the working waterfront, and over in this area here, Back Cove, you lose a lot of the area in there. And that's with a 1.6 foot rise. Storm surges itself add about 4 feet, at about 4 feet to the sea level rise. And then you have to consider wave height on top of that. So you get the sea level rise, but then storm surge and waves add insult to injury and really cause you a lot of the damage. And this is the last slide that I got in Kennebunk, with a 1.6 foot sea level rise by 2050. If you look at these streams up here, this green right here is the 1.6 sea level rise. Is a lot of this area in Kennebunk becomes flooded, and the beach areas themselves also become flooded. And I thought this was interesting too. And with a 1 foot rise of sea level, okay, and we're talking, that's probably getting close to what we are right now. You have a 15 times increase in nuisance flooding. And this is referred to as sunny day flooding. And I know that it is occurring like in places in Florida, whereas it'll be a beautiful day, it's sunny, there's no wind, high tide comes, and it comes up through the drains, and you have a flood in the parking lot or a flood in the building. So 15% increase with a 1 foot rise in sea level. But another thing, and this is in relation to the storms, especially the storms that we've been seeing, with a 1 foot rise, the 100-year storm flood level could likely occur every 10 years. So instead of it being statistically 1 in 100, it's now 1 in 10. So you stand a much greater chance of those storms coming and causing the problems. Okay. With that, it pretty much covers everything about that I wanted to mention about the Maine coast. And if you have any questions, I'd gladly like to hear them.
Thanks so much, Steve. Yeah, questions, if you're more comfortable, you can put them in the chat or you can unmute yourself and ask away.
Yeah.
Peter, you're unmuted. Did you have a question?
Yeah, I don't have a question, but just odd piece of literary information. T.A. Jackson, who is the state geologist that Steve referred to, was the brother-in-law of Ralph Waldo Emerson. So for what it's worth, here's a footnote.
Which makes you wonder if the family was a wealthy family that could afford to send their kids to higher education.
They were prominent. It was a prominent family. Emerson's first wife had a lot of money, and it really subsidized much of his writing career because she died young. He inherited wealth.
You might call them Nepo babies, but I figure that's their good fortune. Hey, Norma.
Steve, I thought I had read someplace some time ago that the rhyolite up at Jasper Beach, there's a whole, and I can't remember if you mentioned it, but there's not a mine, but there's a whole section of rhyolite there that it is what's making the Jasper Beach rocks get eroded and shaped. Do you know if the recent storms had any effect in eroding that deposit of rhyolite, or is that yet to be seen?
I truly don't know because that really was way up the coast compared to where we are. But there's a lot more than just rhyolite there. That is, what everybody wants to call the Jasper.
Right.
But it's really, I don't know what it looks like. But interestingly enough, I went and you've seen what some of the damage at the Wells Reserve. I went to Timber Point here in Biddeford, and I was it was disheartening, I guess, to see it kind of torn up, and the heavy equipment had gone in there to fix it up somewhat, but heavy equipment always makes a mess.
And another point too, that aerial view that you showed of the Little River estuary, and how those, like the little sandbars when the waves come in, be interesting to see and compare a new aerial photo of that now to that one, to see how that changed and how that water eroded over to the causeway, if there's any difference underground, because that was a really good picture showing the depth of the estuary at the mouth of the river. I'm sure there'll be new ones, new pictures.
Lynn's got something here.
Yeah, Steve, do you know why they stopped mining at the Damascata Shell Middens after 3 years? Was it just they were like, we don't need to be doing this, we shouldn't be doing this, or
They pretty much took what they could. In other words,
Okay.
economically, it was no longer feasible.
Okay.
And
But okay, thanks. They would have kept going.
I think, yeah, pretty much it's and I have not been there. It's on my to visit list. But
Yeah, mine too.
I'm thinking that, it's probably they took what they could.
Okay.
Once you exhaust it. I'm surprised they didn't go to the other one.
Right. Lucky they didn't.
Yeah.
Thank you, Steve.
We still have a couple minutes. Oh, Norma, you have another question?
Yeah, I just thought of something else too. You mentioned Sand Beach earlier, Isn't that the place that it was in the news after the last big storm where the hull of the ship was found?
Was it at Sand Beach?
I thought it was. Does anyone else remember that? If that was Sand Beach? I'm pretty sure it was in Acadia, in that area. And that's the only Sand Beach, right? But there was a picture in the paper of a big hull of a ship that had been unearthed. Yeah. More things found.
And the people had said that they're kind of a rush to get into it and look at it before it gets covered in another storm.
Right.